to the arts, and to our understanding of God and of the universe. Is this? Okay, thank you. If you don't mind, I'll do that. I will come down at some point to make a little demonstration, but when I do that, I will put my mask on for you. All right, so there are 4 goals I have for us today. First, I'm going to introduce the concept of the fourfold way, the Quadrivium. I have a tendency to use Latin terms. I think it's kind of fun. It's a little quirky. Quadrivium just means 4 way, or a 4-way, fourfold way is probably a better way to describe it. So I'll introduce that concept. I'm going to detail the history of the role of music in learning and understanding, really the connection between music and philosophy. Third, I'm going to detail the role of the quadrivium in the Middle Ages and how that affected music, both music practice and music theory. And then number 4 will be a little open-ended bit that will involve all of us, and I'll get us started. I want to dream about how, knowing this rich tradition, we can learn like monks today, all right? I think there's a lot to be said that's open-ended, that scientists can't answer, and some wisdom we can learn from our forebears is that sometimes the things we don't understand teach us more than the things we do understand. So, without further ado, I'd like to get started. So to really get started, I thought it would be a good idea to bring a special guest here today. His name is Pythagoras. He's a very famous Greek mathematician, and anyone who took high school geometry should have a particular love for Pythagoras. So welcome, Pythagoras. Thank you very much. It's an honor to be in Bloomfield Hills, Michigan with you today. So, I want to tell you something really cool that I learned in Greece about 2,200 years ago, something like that. I want to tell you a little bit about something I discovered. I walked into a cave and I discovered something really, really cool. A blacksmith had these vibrating hammers that were vibrating in this particular way that sounded so consonant. It was almost like the 2 different sounds were one sound. And when I looked at the hammers and studied them carefully, they were of perfect ratios. They fit 1 to 2. You could fit, one was half the size of one. Another was 2/3 the size of another. It's pretty amazing. I'm going to show you. I couldn't find a monochord or a lute. I don't know what you modern people do, but I did talk to Claire Danaher. She said they have a modern replacement that you all call guitar, something like that. So here it is. I'm very old, so technology, they had to give me a lesson here. I'm going to try this out. Let's see if it works. Can you hear that? Very good. All right, I'm going to come and show you something. So I discovered, there we are, something I consider almost magical. Do you see this string on the bottom here? In fact, I'll make it the top string. That's more natural for me. This top string here is held in by a peg on the far right of the guitar. And then right here, there's a little bridge that holds the string taut. So this is an end of the string. And then there's another bridge down here that holds the string tight and taut. And when I pluck that string, it plays that note. But let's say I put my finger halfway across the string somewhere. Do you hear that? Listen to him again. Do you hear how they vibrated together when I quickly let my finger off? They almost sound like the same note, right? Do they sound different? What about these two? They're perfectly consonant. They resonate together. Well, let's try a couple others. So that's a ratio of 2 to 1, an octave. If you're interested, there's on the back of your handout, you can actually see this. There's a picture of a guitar doing exactly what I'm doing. Now, what if, okay, so that's the ratio of 2 to 1. What about 3 to 2? So this is the whole string. And this is just 2/3 of it vibrating now. That sounds good together, doesn't it? So here's the octave, half the string, and then 2/3 of it. Okay, so we did 1 and 2, and 2 and 3. What about 3 and 4? Whoop, there it is. So if you look at it, I'll move out so you can see it better. This is 3/4 of the length of that string. Let's give Pythagoras a hand. Thank you, Pythagoras. Okay. Got a little warm there. Let me just disconnect this here. Here we are. Okay, great. So, it's a little complicated. It's a little esoteric, but those sounds fit together. They sound somewhat consonant. You know, sometimes you can hear what sounds like an out-of-tune choir where the notes beat against each other and there's maybe a dissonance versus a consonance, or cacophony versus harmony. That's considered a natural harmony. So what Pythagoras thought, and what Pythagoras' philosophical colleagues at the time thought, and I'll get into more detail later, is that the idea of those notes vibrating together and fitting right together and feeling right together was a proof of divinity, was a proof that the universe was ordered. And it wasn't just in music that this was noticed. You noticed what I did, it was a musical experiment, yes, but it also was a geometric experiment, right? I divided a vibrating string in half. And as we know in modern physics, when you double the wavelength, what happens to the frequency? It halves. Yeah? That means if you have a string that's 2 feet long and you pluck it and it vibrates, if you get one, let's say it vibrates 100 times per second. If you have a 4-foot string and you pluck it, it only vibrates 50 a second. When I played those 2 notes, the one that was half the length and the one that was double, that piece of metal vibrating on this wooden membrane of the guitar vibrated at double the speed. And that is a miracle, right? We could think, yeah, that's just how it is. But the Greeks asked the question, yeah, but that's how it is. Why? Why is half a thing? Why do two halves make a whole? Why do 2 quarters make a half? How does division work? Basically, I feel that giving this presentation in this building is particularly interesting because this is an architectural wonder. It's a wonder of geometry, right? And the way this heavy concrete structure floats above the ground effortlessly is because of the simple things that the Greeks were talking about, that Pythagoras discovered and was so excited about many, many moons ago, which is that a series of simple ratios can explain the physical wonders of the world. And not just the world that we walk around and look around, but also the cosmos and the stars, the movement of the stars. So it's pretty darn cool. Other things, for instance, and they're all these things are measurable and universal, and that's what amazed the Greeks too. So, okay, let's talk about geometry. The Pythagorean theorem, right? That if you square two of the sides of a triangle and add that, the result is equal to the square of the other side. A squared plus B squared equals C squared. It just works. And it's a measurable, universal truth. So why I find this interesting is that somehow this is all ordered, right? This isn't random. As people of faith, we believe that. That's part of what we believe, is that there's an order to the universe from God. But do you ever really take a second and question, why do I believe that? It was St. Thomas Aquinas, a medieval theologian himself and philosopher, who said, faith without doubt isn't true faith. So we have to ask these questions. And the cool thing is that Western civilization has been answering them in a wild way for millennia. A beautiful way. All right, let's talk about the quadrivium then. So the fourfold path that came from Greek philosophy and mathematics is essentially the study of those ratios, numbers, and their relationship to one another and their appearance in the natural world. The quadrivium consists of four components. Number one is arithmetic, math. That's just pure number. It's the study of number. And it isn't just the study of the number 4, right? It's what's 4 plus 7. So it's number in relationship. Number 2 is geometry. Geometry is the study of number in space. Very good, exactly. So number in space. Music is the study of number in time. Yeah, exactly. And then the most interesting, I think, is astronomy, which is the study of number in space and in time. And I'll explain that a little bit more when we get to talking about Boethius, who was the one who came up with the concept of the quadrivium. But the idea being, before we understood the cosmos, really, and the idea of planets, the idea was, and stars, they were just moving objects in the sky. So it was a moving number, right? Number in time means that we're looking at how something moves and kind of calculating things based on the stars. And you think about how we've calculated time as humans, we have always looked to the skies, haven't we? All right, it's pretty cool. So the Quadrivium Way of Life is this, and we're going in concentric circles here. I'm going to come back and explain things as we go. The entire natural world, seen and unseen, is governed by these simple ratios. We see them in the skies, we see them in shapes, and we see them in the division of the monochord, our fancy little guitar here. Therefore, music, which is founded on these ratios, affects the soul and can put disorder into order. It can bring harmony out of dissonance. When we allow ourselves to resonate with the sound of the universe, the song of the universe, we are restored to harmony with ourselves, with others, and with God. So, if you think I'm making this up, let me read you a quote from Plato. God gave us a voice and hearing for this purpose, I believe. Speech tends and contributes very much toward this end, and every use of the musical voice was given for the sake of harmony. Harmony, which has motions that are congruent and akin to the dissonant wanderings of our soul, was given to us by the muses to deploy with wisdom, not for pleasure, just for pleasure's sake, devoid of reason, as is now seen to be its use, which that's true today too, isn't it? But so that through music, we may calm the dissonant revolutions in our souls and make of them a harmony consonant with itself and with others. Rhythm, too, is dedicated to that purpose, so that we may very aptly temper in ourselves an immoderate character lacking grace. It's a long-winded philosophical way of saying things fall into place in our right order, right? That music, believed by the Greeks all the way through the late Middle Ages, was thought to just have a universal power beyond our understanding that just was something that harmonized us. It also meant, though, if you made music that wasn't thoughtful and music that was really dissonant, there was thought that that actually could affect you in an evil way and disquiet your spirit and cause issues. Here's a quote from one of the great medieval scholars. His name's Calvin Bauer from University of Notre Dame. Of all the mathematical disciplines, music is unique, for music is the most sensual of the arts and can thus influence behavior, can determine character. Boethius, the founder of the fourfold way, the Quadrivium, argued that the rational person must cultivate a music structured according to principles that are themselves rational, principles that reflected the most consonant essences found in that species of quantity, that's a wild concept, expressed in beautiful ratios and proportions. 1 to 2, which we heard was beautiful. 2 to 3 was beautiful. And 3 to 4, so beautiful. For Boethius, and indeed for all the Pythagoreans and the Neoplatonists, which people who studied Plato starting in the time where the Roman Empire was in decline. We're looking in the 5th, 6th century. Those essences were discovered neither by rational deduction nor by induction from sensual experience. They were revealed truths. So isn't that cool? The idea that these numbers, these perfect things, it wasn't just something we discovered and came up with as humans, this is going to be our system. The idea is, no, these ratios transcend all cultures. These ratios just are. If we believe that this world is spinning at tens of thousands of miles an hour, barreling around the sun right now, that only works if we buy into this idea of these simple ratios, universal truths governing our world. And I'll talk about what that means and how that means we can live like monks and kind of, for lack of a less colloquial way of saying it, kind of lean in and chill out into the goodness of this world and of God's idea about how this all works. So, my final setup bit here is from antiquity until the Renaissance, almost 2,000 years of Western history. The study of music, more than anything else, was a foundational study of the order of the natural world. It was the foundation for philosophy, theology, law, medicine, so forth. You had to study music before you could study medicine or law. Throughout the history of Western music, there has been a dialectic, kind of a two-pole situation between music practice and music theory. Right? I'm talking about music in a very heady way, right? I plucked one string and didn't play any harmony or make a song. But in the study of music, really until the Renaissance, there was this correlating dichotomy between interacting with music in a conscious way, rational way, and then our subconscious way, right? The way we enjoy music, the way we feel about music. I don't like the word subconscious because subconscious sounds, oh, I'm just kind of going on instinct, right? But I'd like to say it's deeper than a conscious way, right? That we think deeper than consciousness because our subconscious mind is so much more powerful than our conscious and rational mind. So there's always been this dichotomy between the two. For instance, when Pythagoras was listening to the hammers and talking about the ratios, Greeks were playing folk songs and playing on lutes and playing chords and doing things that didn't fit in the system. The idea of music theory and music practice working together have always been in tension to this day. Go home and listen to some Schoenberg if you want an example of what that is, right? 12-tone serialism, modern music that sounds like cacophony or chaos to us. Throughout late antiquity until the Renaissance, that separation between music theory and music practice was stark. It was very strong. For the great thinkers of that time, music study gives access to this idea of the harmony of the spheres, the language of divinity. That being that the very universe, the planets themselves, vibrate with a particular pitch and a particular sound. Interestingly enough, Christians as great as St. Augustine adopted that idea and said, yep, it's absolutely part of our tradition. So it's transcended all cultures. All right, quick breath break. I'm going to go grab a big blue book, and then we're going to get into the history of the quadrivium with a little more detail. Okay. So, music appears in classical Roman culture as part of the fundamental curriculum of the orator. Who is an orator? Somebody who gives great speeches, right? Somebody who riles people up and stirs people to action. I like to think of like a political stump speech. That's oration. So, music wasn't considered part of the quadrivium in ancient Rome. It was seen as an art, much as it is now. So it was a useful thing to study to make you a better Roman citizen. Interestingly enough, when I was reading about this, I thought this was kind of a fun bit of trivia to throw in for you. Music was considered a liberal art. The term liberal arts originated in ancient Rome. The orator and other Roman citizens who were free of servitude or any commercial concerns were called homo liber, which is Latin for free man. So the disciplines that I talked about there in preparation for oration were called the artes liberales, the arts for the free person. So somebody who has time to do whatever, stirs them to a greater understanding of the universe and a greater, just their place in the universe and growth and study would study these free arts. Let's go to Plato, back in Greece. His writing Timaeus narrated a world creator's use of those simple ratios we talked about in ordering the world visible and invisible. Followers of Plato call that the world soul. All right, so that there's this energy in the universe that is the world soul. Cicero, 1st century BC in Greece, wrote something called the Dream of Scipio. It's a primary classical source of the idea of a harmony of the spheres, the idea that the universe has a note. Here's Calvin Bauer's translation of a bit of Cicero as a little summary. When viewing the marvels of the cosmos, Cicero's soul inquires concerning the nature of the wondrous sound filling its ears. He is told that the harmony results from the motion of the spheres that are spaced according to musical ratios. Only souls who search for truth, along with certain musicians who can imitate the heavenly order in their playing and singing, can hear these celestial tones. It's kind of neat. The idea that it's only through our study that we can understand these universal truths. And also the idea that when you look in the sky with a telescope, or maybe even with the bare eye and have a measuring device, the distance between two planets is considered a note. It sounds wild to us, right? But If you think about that, that's just a line. It's a division of a line. And the same is true in the sky, right? When we look at constellations, all the stars are points, and then there are all these little lines between them. Universal ratios, understanding from the natural world universal truths. So that was cool. In ancient Rome, that kind of moved in and out of different thinkers. A key thing, though, is that Augustine in the 4th century, right? So an early Christian saint endorsed this view about the harmony of the spheres and wrote about it significantly. He also was essential in moving this classical understanding of ratios and numbers as proof of God, as universal truth, into a post-classical world. Basically, since Augustine wrote about it and liked it, when the Roman Empire fell and we moved into fiefdoms and Frankish kingdoms and Iberian kingdoms and all the sort of a diaspora of Roman knowledge and understanding, it was okay because it was Christian. That's basically the way thinkers and monks thought about it at that time. So quadrivium as a concept, if you remember one name connected to quadrivium, it's on your sheet here. I'm kind of at the bottom underneath here. Also, I should make mention that this has a handy little table 5.2 from Calvin Bauer's work in here, that talks about the liberal arts, and you can see how they changed over time, right? In the 1st century BCE, music fits in with grammar, rhetoric, arithmetic, geometry. It's more like it is now. It's just a subject you study as part of training to be an orator or an architect or a doctor. But this guy here, very important, Boethius. Animus Manlius Severinus Boethius. Roman senator, lived from 480 to 525. It's kind of a short life, I'll tell you in a second. He was a Roman senator and philosopher, and he created the quadrivium. Boethius was a classical scholar, and he was fluent in Greek, and he translated lots and lots of writings, Plato, Aristotle, Cicero, into Latin and put them into a compendium. Lots of literature, lots of philosophical work, lots of scientific work, lots of work on music and the cosmos and arithmetic and geometry. So his work was foundational for the future of this knowledge moving into the Middle Ages. Boethius, I'll tell you a little bit about him. Roman senator. He died in 525, and it was unfortunate. He was actually put to death. He was defending a friend of his who was on trial for treason, and he was just doing his duty as a philosopher and a lawyer, but he got caught up in the whole thing and was executed himself. It had something to do with the Arian heresy, and I'm not going to get into it. That's a different lecture, and not for a musician to give. So Boethius, in translating Plato's Republic, specifically Book 7, discovered this idea of music and astronomy in particular being pathways to understanding the universe. I'm going to read you the Pythagoras Myth. Remember when Pythagoras was here with his fancy Greek hair? Well, he made reference to a cave, right? That he walked into this cave and heard something, and that helped him discover these ratios. Here's what Boethius wrote about Pythagoras. Pythagoras had long sought rational criteria to determine musical consonances, things that sound good together. One day, by divine guidance, he passed a blacksmith from which the sounds of musical harmony emerged. He went into the shop with amazement, for pitches sounding consonant or in tune, resonant with each other, seemed to come from the blacksmith's hammers. He examined the weights of the hammers and discovered one weighed 12 pounds, a second 9 pounds, a third one 8 pounds, and the fourth hammer 6 pounds. The hammers of 12 and 6 pounds sounded the octave. that interval in which the two pitches were most identical. 12 pounds, 6 pounds. The hammers of 12 and 8, as well as those of the 9 and 6 pounds, sounded the fifth, an interval which, next to the octave, was the most beautiful. 12, 8. The hammers of 12 and 9 pounds, as well as those of 8 and 6, sounded a fourth, the interval that seemed to be the smallest consonants and the furthest away from perfect unity. 12 and 9. So when you look at the lengths, that's, let's say, 12 inches, 9 inches. And it's the ratio you see on the back there, 3/4, right? So, in this manner, Pythagoras discovered the ratios, the immutable, unchanging essences of musical harmony. The octave lay in the ratio of 2:1. The fifth was determined by the ratio of 3:2, and the fourth was found in the ratio of 4:3. Moreover, since the basic building block of music, the tone, was the difference between a fourth and a fifth. So now we're getting into adding ratios, which is complex. The ratio of that interval was the difference between 3:2 and 4:3, which is 9:8. All right, that's kind of a weird one, but when we subtract or add ratios, it's actually a multiplication. Trust me, I had to review like high school math to do this talk. That's kind of why I was terrified of it, but it's true. So, for instance, this is our length of 8 and 9. And if we listen, that's a whole step. Do, re, mi. Those are whole tones. Ratio of 9 being the longer to 8 being the shorter. And the cool thing is we can construct that ourselves using, is it called the compass? Is that the unit from high school geometry? The little thing with 2 points? It's kind of neat. It's super nerdy, but it's kind of neat. Anyway, Boethius, to use a colloquial term, was stoked about this when he was reading it in Plato's Republic and reading about Pythagoras. So, as you can see, and as we talked about in the beginning, Boethius said, no, these different ways of the liberal arts, it's too imprecise. We need to study number. It's all about number. That's the foundation of everything. So we'll study arithmetic, music, geometry, and astronomy. Let's fast forward. We're skipping a lot of stuff because this is a dense topic. Work by medieval theorists, including Hucbald and Guido of Arezzo. If you came to my chant talk, you heard about Guido. He's the one who taught us the sound of music. I see Pastor Manisha back there, and we talked about do, re, mi, the foundation, the beginning. We're getting deeper. Those theorists integrated the philosophical study of music with the actual chanting that was happening. Remember how I was talking about the Greeks had the monochord, the philosophers, and then you had the folk music? Well, in the Middle Ages, these theorists in the 10th and 11th century tried to bring it together. They did it all wrong, and that wasn't resolved until the 16th century, which I'm not going to get into because that's a different talk. But that's when music theory, the study of what we do. Christopher Wells and I had to take music theory from the very beginning when we were playing the black keys only. You had a performance book and a theory book. If you've ever taken piano lessons, you study performance and theory, music and the theory at the same time. That is a result of the Quadrivium, and that's a result of this way of learning. Even into the early Renaissance, the idea of a harmony of the spheres or a universal harmony was widely accepted. All right? The challenge came when we got into the 16th century, really, and even into the 17th. As studies of physics and astronomy progressed, the idea of a harmony of the spheres diminished. For example, Renaissance astronomers discovered there's no sound in space, right? Do you remember that from science class? There's no sound in space. Why not? Well, there's no medium through which a vibration can travel. But also, in the late 16th century, even among musical thinkers, there was an anti-theory reaction that was happening. Basically, with the Renaissance and the rediscovery of Greek mythology and Greek math and even democracy, the Greek politics, eventually they're like, listen, people, the theorists even said, there's just too much theory. Let's jam, let's make some music. So there was an anti-theoretical reaction in the late 16th century, which is what gave us opera. I'll talk about that in a minute. In the late Renaissance then, music moved again out of this scientific proof of God sphere into part of a quartet of arts. These include, and the Italians were the ones who came up with this, grammar, rhetoric, poetry, and music. The idea being that good grammar, good rhetoric, poetry, elocution, and music can move the soul. They're arts that move us and change us. And they don't necessarily need to be studied. We can trust our instincts and just do it. So this led directly to new musical forms, especially opera. Opera was a marriage of the rediscovered Greek tragedy, right? A form of you could call it theater or play, with the current practices of music that were happening at that time. So when the Renaissance Italians read about these Greek tragedies, they said, okay, there's a lute, just a little guitar-like instrument, that's playing some little chords, and then a singer sings one line only, no harmony. The lute sets it up for the singer, and the singer goes. And that's where we got the idea of recitative. If you've listened to opera and you hear a chord play, and then the singer goes, and the music also is rhetorical, where if the singer is talking about something that really hurts, they might sing, up here, oh, and then come back down. Or if they're really sad, they weep, they weep, they weep. These little techniques came to be a way of recreating this Greek tragedy idea that moves us, but they used music that was that's where we got opera. It's a cultural hodgepodge. It's kind of cool. Anyway, that's a whole other talk too. It's a dangerous topic we're in here. All right, so then text painting also, where the words of the music are connected to the notes, and it all fits together to try to move us, move our souls. So music as art more than as science. I'm going to fast forward not many, but a few centuries, because a lot of stuff happened in between. For instance, Bach, Mozart, Beethoven, Brahms. Love to pause there, but we're talking about music in the Quadrivium, music as science. So by the time you get to the 20th century, music is not Max Planck, Albert Einstein, and others led to the development of quantum mechanics. Have you ever heard of definition? Someone correct me if I'm wrong on this, because again, I'm a musician, I can count to 4. Can't explain. All right? So there's certain things when you get down to the protons and the neutrons and the electrons that all the classic laws of physics explain well. But when you get that small, it doesn't make sense anymore. Certain things don't work. It has vibration and wave. For instance, I think the definition of and the laws of physics that we thought were solid, they can give or take. Everything's a little relative. But if it's the universe. So that's the key I want to share with you today. Am I right? I have no idea. But is it cool? Absolutely. Okay, brief little tour, and I'm kind of off sheet here, but actually this little bit is on sheet. On the guitar side of your handout, this is how monks learned. The talk's called Learn Like a Monk, right? This is how they did it. So we say monks, but I also want to say nuns, because in particular, Hildegard of Bingen, a great German mystic in the High Middle Ages, was a master of the quadrivium. I mean, she was a scientist, she was a poet, she was a doctor, she created herbal medicines, but she also was an incredible musician. Her chants are some of the coolest chant that exists. And here's how she would have learned. First, she would have started with something called the trivium, which is the foundation. She'd learn her grammar, she'd learn her logic, and she would learn her rhetoric. Rhetoric is the art of the back and forth, the dialogue between minds. Next, you move into the low faculty of arts, also known as the quadrivium. That's your arithmetic, pure number, your geometry, your number in space, your music, your number in time, and your astronomy, both number in time and space. Take a quick pause here to explain Boethius' way of talking about number. Boethius described two types of number. And I love this, because this is something that I just think about a lot. Magnitude and multitude. The way I like to explain this is analog or digital. If you have an analog or a digital clock, tick, tick, it's second 1, 2, 3, 4, 5, 6 under digital clock, right? There's nothing between the 1 and the 2. Each number is its own unity, indivisible, a set quantity. Now, on an analog clock, and one of my predecessors, Aaron Tan, put an analog clock on the organ console in the church, and I'm so pleased about that because I'm very anti-digital ticking clocks because you hear the note anyway. But the other thing it reminds you of is the infinite nature of the division of time, right? A sweep motion clock, between the seconds it goes 1, 1.1, 1.2, 1.3. Like all those little divisions are being passed. Every single division between second 1 and second 2, an infinite number of possibilities between 1 and 2 are being passed and moved through. It's mind-blowingly cool. And none of them is its own unity, right? Because when we look at digital, 1, 2, those are indivisible in a digital circumstance. In a multitude circumstance, Boethius would call that. But in a magnitude, where it just goes, infinity, it's neat. In Boethius' mind, following the minds of the Greeks, geometry was dealing with magnitude, not multitude. Isn't that interesting? Geometry, because if you have a line, for instance, pencil. Pencil is my unit, all right? So the idea is I could have a pencil this long, I could have a pencil this long. A squared plus B squared is still going to equal C squared if I make a triangle of different pencils. So it's analog. Where in music, the idea was you only have a 12-pound hammer. You only have a 9-pound hammer, a 6-pound hammer. Eventually, of course, you can slide a string, and a trombone slide is digital, right? Infinite number of possibilities between the notes. This just gives you a quick insight into the Greek mind, and then I'll move off of this. This is a deep cut tangent. But to Boethius, arithmetic was pure number. Geometry was the study of magnitudes. So the analog, the in-between. But magnitudes that were still, immovable magnitudes. Astronomy was the study of mobile magnitudes, and that's mind-blowingly cool. Because if you think about it, all right, I can see that asteroid or that planet is moving, that star is moving over the course of days. It looks like a couple of inches to me, but I know that that's not right because I'm so far away from it. I have no idea what that distance is, but I know it's a magnitude, and it's moving. And then music is the study of multitudes, which is so wild that music is the fixed stuff. Music is solid. Anyway, there you go. So back to the quadrivium. Hildegard first studied her grammar, her logic, her rhetoric. Then she studied her quadrivium, so she got into her numbers. And then, only after having that study, including music, could she study medicine, law, or theology. So the idea being, music is a study of how our universe works and how we vibrate. All right, so to wrap it up, and this is the open-ended bit, it's very heady and very complex. I have trouble wrapping my mind around it, but I think it's cool because it has implications for how we live today. How do we learn like a monk today? First, we look at the ratios, and we look at how excited Pythagoras got. He only was excited because he happened to listen to what was going on in that blacksmith's shop. And then he observed, and he took time to measure and just take it in. So we can learn like a monk by listening, looking, feeling, tasting, smelling. Even in this moment, let's do it. All right, back to earth for a minute. I'm sorry. That felt really cool, actually. I haven't done that in a while. Our cell phones can be such a distraction from being alive to the world, and I'm guilty. When we take time, we will notice incredible patterns all around us. When's the last time you took a good look at a leaf or a snowflake? Quick story. I was a junior in college, and I was commuting to the music school at that time. And it was a very snowy day. I was going to my organ lesson. I'm walking down a hill, Bates Drive, and there were big, puffy, light snowflakes falling. I had gloves on, black gloves. And a snowflake fell right on the top of my hand as I was just strolling along. And I just looked at it, and I saw the pattern. Maybe you've heard the word tessellation before. It's the idea of geometric patterns that fit together and create a giant, basically a tapestry of the same repeating over and over. It's an incredible thing. And I'm looking at the snowflake, and I just couldn't believe how complicatedly, congruent everything was, and how beautiful all the angles, everything fit so well together, and it was tiny. And then I got to the organ studio, and I still had it on my hand. It was not melted, thanks to the glove. And I looked up at the sky, and I noticed the uncountable number of snowflakes falling all around me that were equally interesting and beautiful. And I thought, holy smokes, who am I? What am I to fit into this incredible universe? It's incredible. So I walked into my organ lesson, and Professor Kibbe said, "How you doing, Joe?" I said, "I'm really good." He said, "What's going on?" I said, "Well, I just had this experience with a snowflake." So we didn't touch the keyboard that day. He took me into his little office in there, and he apparently is this math mind. He was talking about geometric tessellations and all these different geometric rules and how it's this incredible foundation of the order of the universe. And he was getting really into it. And I'm like, okay, so this is why this guy's an organ professor. He's been pursuing these truths, and they've changed his life and made him an incredible musician, and his music resonates with so many people, but he's in touch with it beyond music. It's that music is just part of the fabric of the universe. I mean, Johann Sebastian Bach, who Professor Kibbe is known for his interpretation of Bach, was absolutely fascinated with number and pattern. He has a piece about the 10 Commandments as part of his little catechism where he repeats the number 10 over and over and hides it in the music. Anyway, when thinkers get thinking, and where there's beautiful art, where there's stuff that moves us subconsciously, oftentimes there's incredible conscious work around the beauty of the universe happening. Okay. I'm going to say that these patterns can't be random. When I looked at those snowflakes, I said, this can't be random. They suggest design. Or, if you're not willing to give me that, if you're atheistic, I would say they at least suggest a powerful energy that galvanizes and is galvanizing the universe into order. As a Christian, I would say, the kingdom of God is being worked out. It's coming, right? It's happening. It's a moving thing. This is key. This means that everything, everyone, every time, everywhere has a purpose. Which means something more. It means that you matter. It means that you yourself are an incredible tapestry of these patterns. You are buzzing with the effervescent, the bubbling over energy of the entire cosmos. You belong. You belong to it, and you are it. You are the very fabric of this world. The only reason we understand this stuff is because we are this stuff, and it's beautiful and it's good, right? It's just like in the story of creation. And God saw that it was good, right? Vibration, music, suggests something, though. Music can't just happen in isolation. There's always relationship. Relationships matter. And that's what we can learn from our integralist monk and nun forebears. There's harmony and there's discord. In order for harmony to happen, we have to let go of whatever our note is, whatever our idea is, and resonate with the greater truth. I think Jesus does that very well when he says to us, call no man on earth your father, because you only have one Father in heaven and you are all brethren. That means when we're not vibrating together, we have to look beyond each of our notes, each of our string lengths, each of our hammer weights, and recognize the universal truth that's trying to vibrate us into consonance. Change our lives, right? In all the great world religions, detachment is the most important thing we do, right? And that's an idea of letting go of our own idea of who we are and becoming created more, day by day, anew in the image and likeness of God as we've come to know God through God's revelation. So it's heavy stuff, people. But it is gospel because it is good news. I could go on forever about it, but this is a multitude, and we have reached the end point of this unity. I'm happy to take questions, though. Questions, concerns, dreams? And the interesting thing about that, Joe, is that, I mean, really, it's only a modern thing that music wasn't a foundational study before law. So it's cool how you see that even now as someone who studied law in modern times. Cool observation. Is there another question? I don't know, but I would guess so. I would absolutely guess so. Why else would someone write about a harmonious blacksmith? It's such an odd. I'm going to research it, and I'm going to let you know. Thank you for that. That's very cool. All right. Oh, please. I love that. So that comment was, analog music is more pleasing to us than digital music. I'm going to take that and extrapolate it for just a second because it's brilliant. And this goes into something that I'm really into, which is a definition of beauty. All right, where am I going to start? 3 seconds, my brain will kick back in. Throughout history, I mentioned this tension between music practice and music theory. Music theory would say the note has to be perfect, the tuning has to be exact, everything has to be exactly right. But music practice has always been a little looser than that. Listening to theory, or even looking at a building that's just perfectly clean, nothing superfluous, nothing out of form. It's nice, but there's something that doesn't tug at the heart as much. The analog, the imperfection, the spontaneity is what moves us. Let me give you my definition of beauty. I believe that beauty is goodness of form that has some sort of a human variance that cannot be accounted for, and that makes it good. For instance, think of a supermodel, all right? You got some supermodel and beautiful. If you ever look really carefully at a supermodel's face, the eyes will be a little off, or there'll be a mole on one side. There's this classical perfection, right? Symmetry, everything's there. But there are always these minor, human, inexplicable variations from the norm. When you look at great musicians like Bach wasn't much of an innovator. Bach synthesized all these different musical traditions, and then he just kind of lived it. He kind of just was him. And sometimes he adds a chunk of music that doesn't really belong, but it fits because it's his heart is singing, yeah? So I love that. Analog music, as you define it, is beautiful because it's variance from that perfect norm. Some theologian, I don't know who it is, once said, we're not called to be perfect, we're called to be fruitful. And you can't be fruitful without occasionally going off the grid or going off the map a little bit. Talking about beauty is a whole different avenue. So, cool. Thank you for that. Yeah, I love to improvise. Part of the reason I like to improvise is that I was a very bad sight reader for a long time when I was a kid because I have mild dyslexia. So it took me longer to read, and that's caught up with time most of the time. Christopher knows when the mistakes happen. He's very aware. Anyway, good. Well, thank you, friends. It was a pleasure.
Thank you so much, Joe. Lovely. And if any of this resonated with you, like that string down there, we are going to have another presentation, Music and Meaning, that is going to take place in St. Dunstan's Chapel. Can you do me a favor? Can you go and play a C major chord on the piano? And we're going to argue that is completely out of tune. Mind you, the Temple Beth has a beautiful Steinway piano, and it's in tune. Play it again. We're going to argue that's completely out of tune. Stay tuned for the presentation in St. Dunstan's Chapel on mean tone tuning. Have a wonderful day.